Hey guys, this is the 2015 question number 4. A researcher conducted a medical study to investigate whether taking a low-dose aspirin reduces the chance of developing colon cancer. As part of this study, 1,000 adult volunteers were randomly assigned to one of two groups. Half of the volunteers were assigned to the experimental group that took a low-dose aspirin each day, and the other half were assigned to the control group that took a placebo each day. At the end of 6 years, 15 of the people who took the low-dose aspirin developed colon cancer, and 26 of the people who took the placebo had developed colon cancer. At the significance level of 0.05, do the data provide convincing evidence that taking a low-dose aspirin will reduce the chance of developing colon cancer among all people? So this is clearly a hypothesis test. Your first thing is to decide whether it's a hypothesis test or a confidence interval. Alpha equals 0.05 tells us it's going to be a hypothesis test. Second, for confidence interval, you would be looking for things like construct an interval, or you'll see the percentage 95% and so on. After you figure out if it's a hypothesis test, you should determine whether it's one sample or two. This is clearly two samples. So your next step is to figure out if it's one sample or two, so we have it's going to be two sample. Afterwards, you should ask yourself, are we talking about mu, in other words, averages, or are we talking about proportions? I don't have a standard deviation anywhere, so I cannot be talking about mu. I'm talking about proportions. So this is a two sample Z prop. Remind yourself that proportions are never T's, never. So let's get to it. We know that for any type of hypothesis test, you're going to need 5 steps. And your first step is the hypothesis and defining the parameters. Don't forget that. So I'm just going to copy what the AP wrote because it's pretty much perfect. So HO would be P1 equals P2. HA is P1 is less than P2. We don't know what P1 and P2 is, so we have to define our parameter. The AP used it as the people who are taking aspirin versus placebo. You just have to say we're P1. Now remember what P1 is. It's a proportion. Represents the population proportions of adults similar to. Please do not say P1 is the aspirin. It's not. P is a proportion. So afterwards, P2 or P placebo is going to be the population proportion of adults similar to those in the study who would have developed colon cancer. Be sure to write out word for word everything. Okay, so that's step 1. Step 2 is our conditions. Remember, there's always 2 conditions, but we're going to have to double it in this case because it's a 2 sample. The first one has to be about the randomization. Now, the people were not chosen at random. They were randomly assigned to one of 2 groups. So that takes care of that. So you have to say, in both cases, the 1,000 people were randomly assigned to both groups. Were randomly assigned to both groups. So you have to say that. So that takes care of randomization. The other part that we know is NP hat 1 has to be greater than 10 or equal to 10. NP hat 2 also has to be greater than 10. And Q hat 1 has to be greater than 10. And Q hat 2 has to be greater than 10. These 4 have to be greater than 10. We know they are because, remember, N is 500. 500 times 15 over 500 is equal to 15. That's great. 500 times 485 over 500 is 485, so that's great. And then we have to do it for the other 2. So we have 500 times 26 over 500. That's 26. That works. And the next one would be, I can't subtract, 474, I believe. I hope so. Okay. So those 4. And then you have to say why you did this. Since NP1, NP2, NQ1, and Q2 are all greater than 10, we can assume the distribution is approximately normal. Okay to proceed. Please do not say since n is greater than 30. This is not an average problem. It's a proportion problem. So now we're done with step 1 and step 2. We need a formula. So let me insert a page below. The formula is going to be statistic minus parameter over the standard deviation of the statistic. Statistic minus parameter over the standard deviation of the statistic. So I'm just going to go like that. You guys can get this from your formula sheet. Please remember to use your formula sheet. And remember that this guy here is going to equal to 0 because the null hypothesis is that we're assuming it's equal to 0. So once we do that, we need to line up the numbers. So we have 15 over... Oops. Sorry, guys. Oh, no. Where the heck is it?